Let's imagine an ordinary Tuesday. You're the lead architect at a company that processes millions of messages every day. Everything's smooth. Your coffee is getting cold, you're half working, half scrolling memes in Slack. And then, the game begins. Marketing launches a new ad campaign, no warning. And your system, which usually handles 5,000 messages per second, suddenly starts receiving 100,000. Dozens of microservices try to read those messages at the same time. Databases start gasping. Servers start melting, literally and figuratively. An hour later, you've got a message from the CEO. Urgent, come to me. Sound familiar? For a lot of people, yes. Today we're breaking down a real architectural scenario that can either save your career or bury it. A company has an application that receives incoming messages. Those messages must be quickly processed by dozens of other applications and microservices. The traffic is wildly uneven, from a few thousand up to 100,000 messages per second. Your goal? Decouple the components, scale reliably under spikes. And the main question, which architecture do you choose? Out of your head, there are 4 options, like a 4 doors. Behind one, success and a promotion. Behind the others, well, you know. Option A. Store messages in Amazon Kinesis Data Analytics. All applications will read and process messages from there. Option B. Deploy the application on Amazon EC2 in an auto-scaling group that scales based on CPU metrics. Option C. Write messages to Amazon Kinesis data streams with a single shard. All applications read from the stream and process messages. Option D. Publish messages to an Amazon SNS topic with one or more Amazon SQSQ subscriptions. All applications process messages from their queues. Alright, think for 15 seconds. Which option would you pick? Remember, 100,000 messages per second, dozens of consumers, need decoupling and scalability. Drop your answer in the comments right now before the explanation. Let's see who nailed it. Let's start with the option that sounds reasonable, but completely misses the point. Option B. Scaling EC2 instances based on CPU metrics. At first glance, more traffic, add more compute. Classic. But the question isn't, how do we add horsepower? The question is, how do we decouple the system? If you just scale servers while services still depend directly on each other, you're treating the symptom, not the disease. When one component slows down, it drags the others with it. That's not architecture, that's panic with extra instances. Option B? Nope. Next, option A, Amazon Kinesis Data Analytics. Sounds fancy. Analytics, real-time, grown-up. But here's the problem. Kinesis Data Analytics is built to analyze streaming data, run SQL-style queries, detect patterns, build real-time insights. It's not designed to be a message buffer that dozens of independent services consume from. Also, it typically reads from streaming sources like Kinesis data streams. It's more of a processing layer than a distribution mechanism. Option A, impressive, but wrong tool. Option C is the trap, because it's almost correct. Kinesis data streams is great for high throughput streaming, but the option says a single shard. A single shard has hard throughput limits, and at 100,000 messages per second, one shard is simply not going to keep up. That's like trying to run Niagara Falls through a garden hose. And there's a second issue. With many consumers reading from the same stream, you're still sharing throughput at the shard level. With dozens of microservices, that becomes contention, everyone fighting for the same pipe. Option C, close, but not the answer as written. And the winner is option D, SNS plus SQS. Let's figure it out why it's such a clean solution. First, messages arrive and get published to an SNS topic. SNS is a loudspeaker. One message in, it broadcasts to subscribers. Second, the subscribers are SQS queues, and each microservice gets its own queue. That's real decoupling. If one service slows down or crashes, nothing collapses. Messages pile up safely in that queue while everything else keeps moving. Third, scalability. SNS and SQS are built for massive throughput and spikes. 100,000 messages per second? This pattern is made for that. Fourth, each service processes at its own speed. Fast consumers race ahead. Slow ones catch up later. No fighting over throughput, no shared bottleneck, no domino effect. This is the fan-out pattern. One message, many recipients, each gets its own copy. Simple, robust, beautiful. So remember the combo, SNS plus SQS. When you need to, decouple components, deliver messages to many consumers, handle violent traffic spikes without chaos, this is your correct answer. Now be honest, what did you pick before the explanation? Drop it in the comments. If you chose option D, nice work. If not, congrats. You're smarter than you were 10 minutes ago. Subscribe if you want more real-world architecture breakdowns like this. And remember, good architecture isn't when everything works, it's when everything still works when something breaks. See you in the next one.